So we are here. Let me share the screen. So do you have anything on your screen right now?
Yes, sir.
Yes.
All right, thank you. All right. So we'll soon end this class. So this is the amplification. This type of attack, this is what happened. The threat actors often use amplification and reflection techniques to create distributed denial of service, DOS attacks. The example in the figure illustrates how an amplification and reflection technique called a small attack is used to overwhelm a target hosts. Okay, so is using both amplification and reflection here to achieve this kind of attack. Address spoofing attacks. IP address spoofing attacks occur when a threat actor creates packets with false source IP address. So an attacker can create a false IP address information to hide sender's identity. So when an attacker wants to hide his original identity, they create a source IP address, a fake one, just to pose as another legitimate user. Okay, so spoofing attacks can be non-blind or blind. So what do we mean by these two? The non-blind spoofing, the threat actor can see the traffic sent between the host and the target. He can see the traffic. The threat actors uses non-blind spoofing to inspect the reply packet from the target. So maybe you have a target, which could be a server, and he pretends to be the legit person. He sends that traffic. The server now replies. So he'll be able to see the content, see the reply information. So one of the tools that they can also deploy is the Wireshark. Wireshark can be used for that to also see the information, but it's not everything. It would not give you deeper information when using the Wireshark. There are other tools that can be used as well. Then blind spoofing. The threat actor cannot see the traffic sent between the host and the target. Blind spoofing uses in DOS. Blind spoofing is used just in DOS attack. What the aim for this type is just to prevent the victim to gain access to the server. Okay, so they can use the amplification and reflection method to prevent the victims from gaining access to the server. Yes.
Oh, yes.
You want to ask a question? Okay. So MAC address spoofing attacks when the threat actors have access to the internal network. So for the MAC address spoofing, that can be done unless you have somebody within that network. Okay. The IP spoofing can be done outside the network. It mustn't be that the person must be inside the network. So the threat actor altered the MAC address of their host to match another known MAC address of a target. Like within a network, what we try to do is we want to prevent what we have known persons that want their system to be on our network. Then those who are unknown, we don't want them to be on our network. So one of the ways you can do that or achieve that is to get the MAC address of the known persons, and there are devices that you can add those MAC address to it in a way that whoever that is unknown will not be able to gain access to that network. But you have threat actors that can pick one of the address of the known person and use it. Okay. So this is just an example of the MAC address spoofing. that's the picture or the diagram we have here. This is a switch, okay, where you can see my cursor. This is a switch. This is a server. This is the threat actor, okay. So the switch has where you have wired port. We have ports where you connect your wired cable. So this is the server connecting a wired cable to this place. This is the threat actor connecting to the same switch. So it means the person must gain physical access to the facility where the switch is, and he now plugs his cable there. So what he will now do is that he will now spoof the MAC address of the server onto his own system. So he will now be the server instead of the legit server. So anyone that sends message or send a request to the server will not really go to the server, but will go to the threat actor, okay, who is this. So because he is able to spoof the same MAC address. So you can see the address here is AABBC of the original system. So that's what I mean by spoofing. So TCP, which is the last one, TCP and UDP vulnerabilities. The TCP and UDP vulnerabilities. So the TCP and UDP, it happens on the transport layer, which is layer 4. Okay, layer 4, a little bit above, that is the one above the network. If you quickly, if you go back, I believe you should recall, this is it. This is it. So this is where the transport. So that's where you have UDP and TCP. So let's quickly go back. Okay. So want to look at the vulnerabilities of that layer. So it has all this information: source port, destination port, sequence number, acknowledgement number. All these are part of the TCP header field. You can look at those ones. So the TCP, its own, is just to make sure that you have a reliable delivery. Then it also control the flow of segments, controls the flow of segments, and also acknowledges that the segment has reached the destination. So all this is a combination of, it's not that the segment works alone without packet. They work together. I've mentioned earlier things like encapsulation. You have encapsulation process from the top to the bottom and bottom to the top. So that is what you have with the TCP. So it maintains what we call the three-way handshake. What we mean by three-way handshake? The system A sending a message to system B. When they send the message, it's this guy that is responsible to making sure that the information reaches system B. So system B replies and says, I received this information, before the port is now open for further conversation. So that's what we mean by these TCP services. So the main thing is reliable delivery, flow control, stateful communication. So this is the three-way handshake I was trying to explain to you. What happens? So the sender send a sync. This is a system A sending to system B. So it can be a ping, it can be a UDP, it can be, that's usually the TCP and UDP. UDP has its own kind of handshake. This is for TCP, please. And all this happen at the level of transport. So this guy, which is A, send a sync to B. B receives it. Then B, the moment he receives it, he send an acknowledgement, which we call it a SYN-ACK. Send a SYN-ACK acknowledgement back to A. So A receives it, then communication is now established between A and B. So other things will now begin to, will now be sent. Okay. So here you can see the sequence. for this guy sending a message to this, it starts with a sequence 100. Okay. So when he's sending the next one, if you check, he sends the first one. That's why you see green. The second one that is sending, which is to establish the communication, you can see the sequence number has changed to 101. You see, it started from 100, then you have 101. Then the same thing goes with this guy. When it's replying, sending back, you will see what? He's sending a sequence number of 300. Okay. And this guy will acknowledge it by adding a 1 to it. That is what you see here. There's a bit of this, but what you should take home is that there's a three-way handshake. The first guy will send, this guy responds, then a communication established between this. That's what we mean by the three-way handshake. So what do attackers do? They take this three-way handshake. The TCP sync flood attack exploits the TCP three-way handshake. So there's what we call TCP sync flood. So like this guy, this is the attacker. He pretends to be the legit guy. So he sends a lot of floods of attack to the web server. In the process, it engages the web server. And the web server, when I say engage, the server gets multiple of this sync information from the threat actor. And the web server sends sync acknowledgement replies and wait to complete the three-way handshake. So when he sends the three-way reply, he's still waiting for the last stage, which is the acknowledgement. And in that process, where this guy, which is the real guy, tries to gain access to the web server, you will see that the web server is not available to attend to him. So this guy engages the web server. The web server responds, but while he's responding, there are so many flaws that is being engaged with. So that is the reason why when this legit person is trying to make his own request, the server is not available to attend to. So that's what we mean by this sync flood. Attackers could engage in the process. This type of attack could deny the legit person from having access to the information. So that's what we mean by this sync flood attack. Okay. Then also another part of this TCP is ending a session. Usually when you start communication, you start session and also you end session. So what we mean end, when you start the conversation, you initiate and say you make a request. Then the remote system will make a reply. Then by the time it makes a reply, you establish, then you begin to have a conversation. It's just like two friends coming together, you greet each other. Good morning. The other person say, yes, good morning. How are you and whatever. Once you are able to greet yourself, you sit down, you start having conversation. But at a point, you need to end the conversation. One person says, I want to go home. It's time for me to go home. Then the other person will not acknowledge and say, okay, yes, it's fine. You can go home, no problem. So that is how you terminate the conversation. So on the network, you have something like that. So this is how, using the TCP, how conversations are terminated. So the first system, once the conversation is done, the first system send a FIN to B. B now receives it. Then B send an acknowledgement. A receives the acknowledgement. Then B now accepts that, yes, let's finish the conversation. It now send another message to A. Send FIN. Then A receives FIN receive. Then after A receives these two, the acknowledge and the FIN, then the whole thing is being terminated by send acknowledgement. So A now send back the acknowledgement to B. B receives it and the conversations are terminated. So even with this, attackers take advantage of it. There are areas they take advantage of. Okay. So UDP also have their own. The UDP that is responsible for like the streaming and whatnot. They have their own header. This is the header. Okay, this is the header. So there are areas attackers take advantage of. So please, the way I just rushed this, I will encourage you guys to take your time to still read through, and especially those who are new into this networking. I will recommend, or maybe what I will do, I'll find like a link, then send to you so that you can also brush through networking essentials, so they can begin to have a full grasp of what we are discussing here. Okay, so I think I will end here to allow you ask a question before we call it a day. Thank you.
Thank you, sir.
So any question? I've been talking for almost like more than an hour.